If you're left still hungry for more garbolium after the last motherboard review, well, here's another helping, but this time around from ASUS, in the form of the Prime A320M-K. There will be some differences in flavors though, so let's dig in. The naked VRMs leave nothing to speculation. 4 core phases, but in a rather thin configuration with one high-side MOSFET and only one low-side MOSFET, and 2 SoC phases in the 2 high-side, 2 low-side MOSFETs configuration. I find the spacing between the coils to be a good design choice, allowing a bit more air from the, what should be now mandatory, downdraft CPU cooler. The board comes with just 2 DIMM slots, and since the name of the board manufacturer starts with AS, they are the 1 latch per slot variant. I am not a big fan of those. I found removing RAM sticks from them to be a bit emotionally challenging. In terms of expansion slots, you get one PCIe X16 slot, typically used for your GPU, and 1 or 2 more single lane slots. But unless you use a single slot workstation GPU, or an APU, then the top X1 slot is going to be obstructed by the GPU. And please do not use APUs in desktops, see the videos on the Ryzen 5 4600G. For storage you get one M.2 slot and 4 SATA connectors. The M.2 slot is placed under the GPU. If you plan to swap your drive to experiment with Linux or for some other reason, this position will make it more difficult. And out of the 4 SATA ports, only the bottom 4 are going to be easy to use. Plugging a SATA cable in the 4th one might be a bit tricky once the GPU is installed. The assortment of pin headers available is rather minimalistic. From left to right we have the COM debug header, then 2 audio headers, the SPDIF out at the top and the regular front panel HD audio. You then have a header to connect a COM serial port, followed by the holes needed by a TPM header, but not the header itself. That is too expensive for this tier of boards. We then have the PHD 6000 header, and since everybody knows what it's used for, I'm not going to elaborate on it. The 2 USB 2.0 headers are followed by the USB 3 variant, and the 2 front panel connectors. FP2 is quite important since a speaker connected there is going to be the only way to diagnose a failed post. You see, the board could use some debug LEDs, but ASUS decided to replace the debug part of the name and functionality with ambient. So yeah, pretty useless. Now, ASUS did place an SPI programming pin header right next to the SPI chip, so a failure to update the BIOS does not mean a dead motherboard. But then they used a 2mm speech header instead of the more common 0.1 inch. ASUS will be ASUS. The rear I/O is tame. 2 PS2 ports that are allegedly used by overclockers to save CPU clock cycles and are just as useful here as it is likely for an overclocker to pick up this motherboard. The video output selection for APUs does have HDMI, but it also has the older D-sub VGA connector. You then get 4 USB 3 ports Type A, 2 USB 2, the gigabit LAN and the audio interface. And thankfully, ASUS did a good job on the microphone input. Have a listen. This is for the ASUS Prime A320M-K, rear input, volume 100%, preamp 0. The easy mode for the BIOS setup utility does allow setting the XMP profile and the rebar option, and also provides access to the fan curve utility. But if you want to access other settings, then you have to go to the advanced mode. Be warned though, setting the core frequency multiplier is not going to be available at all. ASUS will tell you that this is a limitation of the A320 chipset, but Gigabyte, through its A320M-H, shows that this is just a manufacturer option. You do get access to core voltage controls. I always undervolt the AM4 CPUs that I use, and this is pretty much mandatory for 3000 and later Ryzens to keep the core voltage under the limits advised by the silicon manufacturer. DOCP profiles, that is AMD's version of XMP, can be accessed also from the advanced mode. Surprising no one. But something accessible only in advanced mode is the capability of manually setting RAM frequencies and timings. Nice if you want to squeeze out the most of your RAM kit. Just make sure you don't damage it. RAM was quite expensive, at least at the time of recording. TPM and rebar options are also available in the advanced mode, with the first one being limited to FTPM due to the missing TPM pins header. Now, the BIOS setup utility will allow you to tweak the manual fan curve, but the board itself only supports PWM fans for the CPU. If your cooler has 3 pins, then enjoy having its fan running at 100% speed. MSI and Gigabyte fare better. As for the option to be able to save OC profiles in either one of the existing BIOS slots or to a permanent storage, typical USB stick, useful to have when you spend a lot of time tweaking your memory timings, but also a bit a reminder that you cannot change the CPU frequency. If you ask me, this board is a slightly different flavor of the same kind of board like the ASRock A320M-DVS. Similarly puny VRMs, just a 4-pin power connector making the board useful for mostly 65W TDP chips. Now, the ASUS board does have an M.2 slot, but it also has worse placement for the SATA ports and for the PCIe X1 slots. But as I mentioned before, even these boards are good enough to connect a Ryzen 5 to a decent discrete GPU, and using a downdraft cooler will make sure those puny VRMs enjoy more comfortable temperatures. Still, better boards are available, even using the A320 chipset, and we've seen 2 of them already. As for this one, it's time to end it. Thanks for watching, I hope you liked it.